I welcome all the students and faculty members in today's online webinar on process of innovation development and technology readiness level and commercialization of lab technologies and tech transfer by Professor Vaibhav Kulkarni. Our Mechanical Engineering Department, along with Institute Innovation Council, organizes various events to promote innovation and patents, technology readiness, startups, and entrepreneurship. Okay, now I request Dr. S.S. Kulkarni sir, Head of Department of Mechanical Engineering, to welcome our Vice Principal, Dr. S.G. Kulkarni sir, and enlighten on this occasion.
Uh, Respected Honorable Principal Sir, Dr. K.J. Karande, Vice Principal, Dr. H.G. Kulkarni Sir, and today's guest as a speaker, Professor Vaibhav Kulkarni Sir. Everybody know that our institute got 4th ranking under Institute Innovation Council. From last 2 years, we are organizing various kinds of events, competitions, seminars, workshops under Institute Innovation Council, so that the students should participate in various innovative projects to develop their creative thinking, their thinking ability in terms of project work, in terms of various activities. They should participate. So our institute is organizing such kind of events and competitions under Institute Innovation Council. Department of Mechanical Engineering is also ahead in this case. We have already given the session from Professor Vaibhav Kulkarni sir to our 3rd year and 4th year students related to innovative projects, innovative thinking, creative thinking. How should you develop such kind of a projects? Such sessions already we have organized for 3rd year and 4th year students. Today, once again, one Institute Innovation Council seminar is there on process of innovation development. How should you develop the innovative skills and how should you implement it for lab development? How should you commercialize it for the lab development equipments? So such kind of contents are there in today's topic, which is really an innovative theme for this seminar. On behalf of Mechanical Engineering Department, I welcome Professor Vaibhav Kulkarni sir to deliver this session. But before that, I request Dr. H.G. Kulkarni sir to say a few words and welcome today's guest. H.G.K.
Okay, thank you, sir. Now I request Professor R.K. Shinde sir to introduce today's guest, Professor Vaibhav Kulkarni sir. Over to you, sir.
Assistant Professor, Mechanical Department, in jobs and marketing or have completed training have 18 and still how Sir, was as running of
Thank you. Hello, Professor Vaibhav Kulkarni sir has having more than 18 years experience. Sir is a innovation ambassador for IISc and he has guided various sessions for students and faculties. And now sir is working at WIT Solapur and he is the in charge of these IISc activities there. Uh, Thank you, sir. Now, I request Professor Vaibhav Kulkarni, sir, to start his session. Over to you, sir.
Thank you, sir. Thanks for the nice introduction. And now let us, without wasting the time, let us bring back to the discussion area where we want to concentrate on three different sections, because this is a larger topic, you can say, where the three subsets are there. So one is the process of innovation development. One, we want to develop the innovation, how the process happens, that we want to deal in detail. The second aspect and subset of this topic is the technology readiness levels, TRL levels. Along with that, we can have some sort of a introduction to the manufacturing readiness levels and investment readiness levels as well. So IRL and MRL in conjunction with the TRL, I will brief about. The third section and the third subset, which is very important one, is commercialization of lab technologies. The technologies which are developed in our lab, that is the lab, you can say, as a co-working space where the students involved and they do their project work, which is capable of converting that project into a product level, commercializing that technology at your laboratory to a market value product. That is what the third one, commercialization of lab technologies, means. We should develop the lab technologies first, and again, extension of that is technology transfer. So in general, four topics we are going to deal in detail. So it's a big and vast topic to go ahead with. So without wasting any further ado, I will go ahead with sharing the entire screen. And here it goes. Hopefully my screen is now visible to all. Whether the screen is visible, sir? Any quick responses, because I could not able to see now.
Yes, sir. Yes, sir.
Okay, right. Thank you. So the topic is process of innovation development. First one, the technology readiness level, TRL, commercialization of lab technology and technology transfer. So with that, I'm Professor Vaibhav Kulkarni. I'm working as a mentor of change for Atal Innovation Mission, as well as I'm the member of Vernacular Innovation Program of AIM and IIT Delhi, Innovation Ambassador IIC 4.0. These credentials are already been briefed by Gandhari sir. Now we will move ahead with the presentation. So these are the three subsets, and equally we want to give the importance for these three. One is process innovation development, second one TRL, and third one is the commercialization of lab technologies and technology transfer. So how you are going to generate the lab technologies first, and after developing these technologies, how we are going to do the technology transfer, either by the licensing, either by the assignment, exclusive or non-exclusive. What are these subsets that we want to go in detail? Hopefully the content will be very appropriate for you people to work in the process of making your project to a product level. And always keep in mind that we want to have a journey of project to product level. I was also of the same kind of mindset where the students here are involved, where we do projects, we submit the reports, and we get the certification for that you completed this and this topic, and you submitted your project viva happens, and that's all. The project goes out of the curtain. But as you have invested your time, The most important one is you have invested your quality time in producing that project. You have invested some of the investment from your parents' pocket, and you have brought the project to a level where you are submitting before the examiners. Why can't these projects, which we day to day do in our technical institutes, why not these could be converted at a product level? Whatever the money that we are investing, can't we get the return on our investment with these initial contextual meaning? Let us set the context for this on these three lines, that the project to a product journey, we want to make it happen. And with that intention, let us go ahead in this. Hopefully, intention is very clear to the students. If some quick responses from the students, I can get audio responses I should expect from the students, because I couldn't able to see you now. I'm offline in that way. So audio responses I'm expecting from the student. Is it good to go ahead with project to product journey? Is it making any sense to you that project must be converted into a product? Any audio responses I want from you? Can you unmute and give your response? Am I audible?
Yes, sir.
Yes, sir.
Okay, fine. So this is the first one, the process of innovation development. The section 1 we will cover now. So why I am stressing on that part? So 94% of the projects that we do in our technical institute, they remain with the institutes. Only 6%, the chosen few, only the chosen few, they finds the market. And that is what the scenario where we want to bring the change in. The change in the type of projects that we do. Can't we make them to a level where the industry will handhold them, industry will take them ahead, and they will then make it to the commercialization level? Can't we do that? Means, no doubt, at the laboratory level, we are making the projects of a proof of concept levels. So that proof of concept level, what is that? Many terminologies will come in between. So you can just pause me at that time, and you can ask me any clarification or any such type of a abbreviation which comes to you, and you can ask it directly to me that, sir, what is the meaning of this? You can ask. So 94% of the projects that we do in the technical institutes, they remain with the institute. Doesn't have any importance after all. 6%, only the chosen few, they will find the market. And that figures we want to alter. So it should be the other way round, where 6% should remain with the institutes and 94% should go to the market. Okay, let us not go in that much sense in the first year itself. But can't we make it that 40% would go into the market? Can't we make it 10% to go into the market? That percentage we want to improve from 6% to 10%. What is that process of evolution of innovation that we want to go ahead with? So first is the discovery stage, where there are plenty of ideas which comes in our mind. Ideas are nothing but the precise thoughts on a particular situation, accident, condition, incidents, scenario, or scene. So these many terminologies are same. It may be a condition, it may be a situation, it may be an instance, it may be an accident, it may be a scene, or it may be a situation. So any of these may happen, and with this, the idea comes to your mind that why can't we do like this? That idea comes to your mind, and it is a discovery stage. That eureka moment comes to you. Most of the times under shower, that comes, that this is a moment where I have this idea and I want to implement it. But with a flash of light, it just goes away from our mind. And now the discovery stage is with full of thoughts. Idea comes and it gives you a thought process. But there is no direction to these thoughts. So they are just abstract ones. There is no thoughtful process goes inside so that we can streamline all the thoughts which comes to our mind and we can converge them to a fruitful endeavor. Okay, so with that particular intention, we want to start the thoughtful process of making them streamlined. That we call as the invention stage, the second stage. Let me take a pen so that, okay. Yeah. So now this is the streamline of some of the ideas. So here are 4-5 ideas. That ideas we have streamlined, and moreover we have written them on paper. And one paper that is called as a research paper we made and we published. That is the invention stage, where we streamline all our ideas to make them in a right direction, a focused effort, so that we can direct all these thoughts to a particular goal. That goal is to reach this project to a product level. And once this reaches to the masses, this streamline activity is called as innovation. The product that you made would be handled by many. We can call it, for this instance, as users. So users are handling your product. That product to a mass level, we are going to call it as an innovation. So we are describing the process of evolution of innovation, how that innovations are going to happen. Okay, fine. Now, we are from engineering background, and we are comfortable with making the formulas to say what is the mathematical representation of innovations. So a mathematical representation of innovation would be innovation is equal to m plus e multiplied by c raised to x. Okay, what is x? X is something which is a radical one, which all of a sudden comes to your mind. C is the relevant context. It just now, while ago, I had told you that it may be a context, it may be a situation, it may be a condition, it may be an accident, it may be a situation, it may be a scene, or it may be a something which we have gone through the experience. So that is the C1. And all of a sudden, if you could multiply it with a radical thought, which never comes to your mind previously, and that radical thought is the game changer. That is going to change the innovations in a larger extent. What is M and E then? M is your mind. So the investment for the innovation would be the mindset. Mindset of a student, mindset of a faculty member who has the mindset to work for an innovative product. Okay, so M is my mind. What is E? So E is nothing but E is the emotions which are given by as an expression from the user, people, or humans. In other language, we can call it as pain points expressed by the user. If we could able to analyze the latent need, what the user is likely to say, or he may not going to say, but that latent need, if we could able to identify, then we can make a combination of your mindset, then that emotion, and multiply it by the context, and radically you can change it into the innovation. So this is how the innovations, they are going to represent it mathematically. Okay. Now, here is something which distracts your eyes, and innovation is the glue between invention and investment. So here comes the terminology that what do you mean by glue? Glue is something which is bonding two elements. One, at the left hand side, we are having the innovations, and on the right hand, invention, and at the right hand we are having the investments. Investments means the venture capitalist or the series A, series B, series C type of investors, they are ready to pour into your venture. What you have at your disposal? At your disposal, we are having the invention, the invented technology with us. What is going to make a bond between these two? What is going to bridge the gap which is there? Innovation is the only thing which is going to make a bridge between the invention and the investment. And that's why we should able to create the new ideas and new concept. Our inventions with the people's problem directing to the pain points will suggest the solutions. Then if these solutions are appropriate and finds the market, then naturally the investment will happen. Okay, so researchers, they invest their time for transformation of their material money into some sort of a knowledge, and innovation is the transformation of knowledge into money. So this is the start of my session, where innovation is a venture where the transformation of your knowledge into money will happen. And that's why who says this, it matters. So Dr. Jeffrey, who is the owner of 3M, the CEO of 3M. 3M is one of the most innovative company in the world, who has taken the glue as its investment. So the temporary adjustment of the glue, they find it very innovative to produce a product out of it. So the temporary glue adhesive, they have turned it into post-it type of stamps. So the post-it type of notes or the flags that we keep in our files to identify a particular page number, these are being invented by 3M, and most of the tapes and the adhesives which they make, they are world class. So that's why they use the word called as glue. So innovation is the glue between invention and investment, right? Fine. Now, many words I uttered till the start of my session. So let us clarify each and every word that I want to put before you. What is idea? What do you mean by POC? POC means proof of concept. What do you mean by prototyping? What is a pilot? What is MVP? That is minimum viable product. And what is the final product which reaches to the market? So these are again the subsets of the first section, the process of innovation development. So if we are having an entrepreneurial mindset at the start, that is called as a phase one. So at the start, phase one, we go through all this process. And at the end, we are having a phase three, which is a business model development. We can make some money out of it. Okay. So this is a curve by which we have the goal setting first, the problem identification. First, we set the goal for making a project to product journey. That should be ensured by the students, that whether they want to make a project which will fulfill their academic criteria and they will go out of the academic schedules. That is one thing. That is more important. Again, can't they make it the project to a product level? So if they could make it, so naturally the journey will start to make them a entrepreneur who in terms is giving the employment to many. He doesn't seeks the employment, he gives the employment to many of his peers. So problem definition, he identifies a problem, then he does the market research, and after deliberate market research and analysis, he knows what is the potential. So he analyzes the customer. This is altogether about the customer and their discovery. So this is about the customer, who is the key element of this process of business development. So every business is concentrating on the human who is the customer, who is the user of your products. And that's why he is more important. And that's why much of the time is invested to analyze what the need which the customer doesn't say. That is called as a latent need, unsaid need. And that is between the lines, if you could able to observe between the lines what he want to just give you a hint. Depending on that hint, if you could make the products, they will give you a business out of it. After discovering the customer fully, we are having the value proposition. What do you mean by a value proposition? Means many players will come, but what is the value proposition they are? Suppose Rocket Boys is recent web series which is launched on Sony Live app. The first part of that particular web series, I just observed that one. So Dr. Homi Jahangir Baba and Dr. Vikram Sarabhai. So these great personalities of India, and their friendship is portrayed in this Rocket Boys web series. First episode, if you download the Live Sony Live app, it would be free for you. But later, if you want to go ahead, then we need to pay some charges. That is called as freemium. So freemium is the value proposition for Sony Live app. On the same lines, we are having aggregators type of a model. We can have the franchisee type of models. So many such type of a models which could generate, and that gives a value propositions for your entrepreneurial endeavor, you can say. What is the key secret of your entrepreneurial endeavor? That is the value proposition. Then we develop the business model. Then financial or some legalities which are there, like proprietorship business or the partnership type of a business, private limited type of a company, or limited liability type of a company, or finally it could be a private limited company as a whole. Right. Let us go with this one. So first of all, we need to validate the startup idea. Then we need to design the value proposition. Then analyze the market for which we are designing the solution. So this has to be designed on some parameters. These will come in the next slides. And discover your customers. Build your own business model and pitch to the investors. They may be the seed investors. They may be the angel investors. They may be the venture capitalist, or they may be the Series A, Series B, and Series C. Or it may lead to an IPO at the end of your startup. So startup is just a trailer of the business that you want to develop in future. Okay. Now, these are some words which are interlinked. They come several times in your mind, but distinctly we need to identify that what do you mean by proof of concept? What is a prototype? What is a pilot? And what is MVP? There are distinct line and a differentiation factor in identifying the proof of concept, prototype, pilot, and MVP. Okay, so proof of concept is the first one. So if suppose one picture comes for the Chinese, most of the times the Chinese eats the noodles, and while eating the noodle, he attached one fan to the nearby to the particular equipment that he wants to, the sticks with which he is eating that noodle. So he attached one fan. So attaching a fan to a noodle is a proof of concept. Means he wants to develop a technology with some sort of a jugaad. So jugaads are the first relevance of your idea, which gives it a tangibility. Tangibility means something which you can see by your own hands that this is happening. So that is called as a proof of your concept. Otherwise, that idea is remain on your mind. It is not coming out of something which is tangible. Some technology, by some sort of a manufacturing endeavor, can you make it, and can you make it within the time? That is what the prototype is. The big circle which is been shown here is the prototype. What is a prototype? We are going to give some detailing about this prototype because this is a very important step. After developing a prototype, which is a vehicle of inquiry, means user will handle these prototypes and he will give his vital solutions that or feedbacks. So this button is not appropriate. This button should be shifted to this side. Some indications should be there, or whatever the suggestion which comes to his mind that he gives to you, so that repeatedly you can come back to your own model and you can develop that model according to the need of the users. Okay, so what is on the x-axis? We are having a hunch or an idea, something which you got to trigger with that idea, and you are developing for the prototype. So for prototype, we need unit of testing many. So test units should be more for a prototype. The level of its fidelity and completion is fidelity in the sense how integrity of that product, how much integrity of that product with your idea, whether you have developed as per your idea or not. That is called as the word called as fidelity. Then comes the pilot, and then comes the MVP, that is minimum viable product. Okay. Now, proof of concept and prototype, we want to develop within your lab or in your studio. But pilot and minimum viable product, they need to test with the real world. So actual user needs to handle the pilot and minimum viable product. So this is how we want to develop the 4 stages of innovation development. So idea is the first step. The second step, it's a proof of concept. Third one is development of its prototype. Fourth one is development of its pilot. Fifth one would be the minimum viable product. Sixth one will be the deployment, which is commercially available product. Hopefully it is understood by the students. Can I get some responses from you? Is it making any sense to you? लक्षात येते हे आपण जे बोलतोय ते कळतंय? हे टप्पे कळाले सगळ्यांना? Okay.
Yes, sir.
Audio responses I should get from you, because now to shift it, sharing, stop करायचं आणि पुन्हा तिकडे जायचं, it is something difficult. So give some audio responses so that I can test your engagement. It is for you people only, because if you are engaged with this journey, then you will enjoy the journey. Otherwise, this is something which you invest from your parents' pocket, and it just remain with the institute only. If it finds the market, then and then there would be return on your investments. And that's why this initiative by SKN Korti has started in the right direction, so that the journey of a student will start from its project to a product level. Okay. How you are going to test the concept? Testing the feasibility of a crude idea with the basic assumptions for which justifies for the further development. Can we go ahead or not? That would be tested by the proof of concept. The user will say that this is not going to work. Don't do it. Then we need to set back and again think for the new idea. So proof of, I think most of us, we watched the series Shark Tank India. So Shark Tank India, whatever the technologies that are going to launch at that particular web series, that is proof of concept level or prototype level. So they tested in their labs, and they now want to reach to the investors so that they could scale it up to throughout the country or internationally as well. Okay. So this is early stage. This is again, prototype is early stage. Why prototypes we are doing several times? Because prototype is a vehicle of inquiry for the user. User asks many questions to the prototype so that he can get the right answers from the prototype. Whether it satisfies whatever the concept was there developed, is it appropriate as per their need or not? That is tested by the user. And this is early stage evaluation, so that we can fail early, so that we can fail fast, and we can fail cheaper. So this is the mantra of prototype: fail early, fail fast, fail cheap. Okay. Then at the rollout stage, means we are all set to go ahead with the commercial intent, and just we want to check it as a pilot run. Suppose we have manufactured the shampoo sachets, and now we want to deliver it, or washing machine sachets, washing machine powder sachets, and then we want to roll out to the customers. So that is called as a pilot survey, where it is tested with the some of the user groups. So that is called as the sample size. So rollout with the sample size. And finally, the live testing with a mob, where you deploy the first version of your product, test it. If something goes wrong, then you can take it back and you can work again and go for the final product one. So these are the stages of proof of concept, prototype, pilot, and MVP. Hopefully it is understood to you. This is something which a ENT surgeon, he's working on some operation. And if you could see how these operations are handling, so many wires are there, and these many wires, they face many difficulties in handling, and somehow they work with the machineries. This was the gyrus ENT material. And now how the prototype was developed. So this is given to the Stanford people, and they want to develop a product out of it. This was the situation given to them. Then they thought with the doctors are also there, which are the users. Who is going to use the product? So doctors themselves, they are going to use the product. So doctors were there. They are discussing with the doctors, and many things they are discussing. So do you want like this? Do you want like this? How the machine should be? So many times it is not an idea which strucks to the other person, but something if you could show to them that do you want something like this. So one of the employee of Stanford, he goes outside, he take out the drawer, and from that drawer he taken this a marker, a small type of a photo cell, and its product, and then a clip. He adjusted with a 3M tape, and he shown something like this. So there was a peculiar type of a adjustment which doctor wants. Doctor wants this position, and this is more appropriate with what the position the doctor wants. So previously this is not going to come out. So difficulties were there, many difficulties, and doctor wants these positions. Then they could able to develop according to their needs, which satisfies them this position. And this is gyrus ENT experiment, which is actually happened with Stanford, and the doctors are doing the surgeries with these equipments now. So this is something a prototype can do the miracle. Just a prototype, according to their hand movements, they could able to replicate, and that satisfies the need of the doctors. Okay, so this is the importance of prototype. Okay, tangible products we can understand. Tangible in the sense physical products. How you are going to do that in the case of the apps? So this is something the apps are made. So this would be the home screen of these apps, and these would be some of these strips. The user experience, UX and UI interface, that is user interface, is designed on these lines. Okay, these are the post-it stamps developed by 3Ms. Just now I have given you this example of post-it stamp, which is a temporary glue. Okay, this is the first interface of that app. They designed it on the paper. Okay, next they then attach many chapters of that one, that after clicking this, what is going to happen, after clicking this, what is going to happen. Likewise, they develop the total flowchart of particular app tangibility. Tangibly means physically on paper, they could able to visualize the process of how the user is going to handle that particular app. This is for the software one. So some of the links I'm giving it for your ready reckoners. You can later you can reach out to these one. You can take the snapshots of this, and you can reach out to these one, which are very important for you people, so that you can get to know about how it is done in the software industry. Again, software industry, for these, they use agility as a concept, and most of the Uber and physical existence, they use the design thinking technologies. So prototyping allows us to fail early so that we can succeed sooner. This is by David Kelly. Tom and David Kelly, these are the co-founders of IDEO, which is a subset of Stanford University. So this is how the products we are looking at the first stage. But once we develop the prototype, this is the final prototype, every user can ask the questions. There is no entanglement of questions. Sequentially, one by one functionality and one suggestion will come pinpointedly from the user, and then we can develop the product. Okay, this is the prototype. Okay. Finally, to conclude the topic of prototyping, I just give you one hint that prototyping is the conversation you have with your ideas. So this is something which you do with your ideas by prototyping. Some tangible thing that you make and you validate your idea. So tangibility to your ideas is by the vehicle of inquiry called as prototype. If a picture is worth 1,000 words, a prototype is worth of 1,000 meetings. Just by sitting together, just by taking so many rounds of meetings and conversations, it doesn't give any output. A prototype that you want to develop, if any representation of your idea could be made with that prototype, that is going to replace thousands of meetings. Okay, so this is the saying at IDEO. The third part of it, fourth part of it, that is what is MVP. Pilot, we know what is MVP. MVP is the most rudimentary bare bones of the foundations. So sufficient for the early adapters. Early adapters means early customers. So these are the your customers who takes the technology first. So most of the times in startups, it is called as customer acquisition cost. For onboarding one customer, how much you need to pay? That is customer acquisition cost. Early adopters, they tested with the MVP. So something tangible customers can touch and feel, and they can give their pinpointed suggestion to that is a MVP. Fine. Minimum viable product should not be like this. This should be avoided. So it comes to your mind, you develop something and goes for the car. This is going to somewhere, it is going to ruin the process of product development. But if you go stepwise, that first you make like this, then you adjust it with a cycle, then go to 2 motorcycle, then 4-wheeler. So this is going to prove for a longer duration. Okay. Now, product management life cycle. So we now covered the innovation. We know the analysis of innovation, how to validate the market, that we want to see in the next one. So innovation part just now we completed. Now we will go with analysis, development, GTM, that is go to market. Go to market is usually known by GTM. Okay, go to market strategy, and then it's in life, that is the service life of the product and end of the life of the product. So the product goes through these many stages of inception, then it's a development, then maturity. After that maturity, it goes out of the product life cycle. So end of the life of a product is what it is said here. So this is the product life cycle management which we want to showcase. What do you mean by a product now? MVP we have seen. Now what is the product? A pin like this, a safety pin, is also a product. Some of the examples I am going to put before you. Bisleri, yes, it is a FMCG product. A fast moving consumer good like Amul, which is a cooperative endeavor, and it is at Anand. Varghese Kurian is the founder of Amul. He started a cooperative one. This is also a product from that day. What is Google, and what are these small icons which are integrating with Google, like YouTube, then Google Maps and Gmail, Hangout and Chrome and many more, Forms and Android and many things like this, Google Drive as well. So these are the products of Google. Google itself is a product of Alphabet Incorporation. Alphabet Incorporation is the parent company of Google. Google is a product which is not tangible. We can't touch it, but we could experience it. So that is the software. Tangible products like DRDO develops the BrahMos, which has the capacity to take the nuclear weapons along. So BrahMos. Then Bugatti Chiron, we got Bugatti Veyron, we know, and this is the next generation Bugatti Chiron, which has the acceleration around, I think, in 2 minutes it can reach to 10 kilometers or something. That acceleration, it is having a huge machinery to work on the roads. So these are all examples of the product. Does it make sense? Are you understanding the process up to this first stage? That process of innovation development. Now I am stopping here for a while and getting some responses from the students. Is it okay with you?
Yes, sir.
Okay. So types of innovations, there are incremental innovations, there are disruptive innovations, there are radical innovations, and there are architectural innovations. So these are some of the architectural innovations like Xerox and Canon. These are the incremental innovations which Gillette has manufactured so far. So Mark III is what they manufactured in 2016. This is Gillette one. Then the radical innovations like iPhone, they changed all the disruptive type of a technology and they changed the game. Then disruptive type of innovations like upside down refrigerators. So they changed the refrigerators and their concepts. Type 2 innovations, they are again having the architectural innovations, the radical innovations with cycle, incremental innovation with the cycle, and modular innovations like comes into the parts, assembled at some point, and you can go ahead with. So you can just put it in your bag and you can move ahead with these types of modular innovations. It is a cycle itself and you can make it modular one. Okay. Hopefully you understood the types of innovations now. Innovations, where we can pursue the innovations in technology, innovations in product, innovations in process, innovations in finance, innovations in culture, innovations in legal, innovations in the ecosystems. This can happen, innovations all over the world. These are the 50 most innovative companies from the world. The first one is the Apple and the 51 is the Bayer Spray. Okay, so now we come to the second part of our discussion, that is called as technology readiness levels. So once we understood the process of innovation development, now we should know what do you mean by technology readiness levels. So TRL levels we are going to work with. As I briefed you, there are TRLs, there are MRLs, and there are IRLs. This is the just history of TRL, MRL, and IRL, how they developed. TRL started with the NASA headquarters in 1974. NASA started with defining 9 levels of TRLs. Okay, how these 9 levels are. So these 9 levels of technology readiness are. So level which we have invested here, and this presentation was by Ashutosh, who is a faculty at IIT Delhi. He did a very good research in technology readiness levels, and he presented this slide. I just can't resist myself to present it before you. It's a very, you can say this rubrics is something which gives you the total idea of TRLs. Okay, what do you mean by TRL? TRL is the basic idea. Every one of us can understand now. There are 3 subsets now. First one is the science and engineering, science and technology. Second one is the software. For software, the definition will change. And this is medical equipments and medical science. TRLs for these 3 levels would be somewhat different. Okay. So first one is the basic idea. For medical, it would be a basic research. For TRL2, for engineering and software, it would be the same, that concept developed. TRL3 is experimentally proof of concept is tested. For software to test, evaluate the basic idea on the technology levels, that whether that problem is going to solve by this technology or not, whether Arduino is to be used, whether what interface that we want to go ahead with, that you can check it on the paper. whether the technology supports. TRL 3. What is TRL 4? So you have made a prototype out of it, which is able to demonstrate itself at the laboratory, or a component or a system which validates your idea in the laboratory environments. So this is tested at the lab level, or this is more realistic with the industrial systems for software. Something industry part that you are coordinating with. TRL 5, lab scale validation, that is early prototype. Okay. Then prototype demonstration is the TRL 6, which is very important one. Up to our degree level, we are at this level only. So most of the Indians, we manufacture the POCs only. If you see the contribution of Indian nationals to the intellectual property rights in our patent office, India, only 20% of the patents they are filing, they are of the level of proof of concept, and only 20% is the percentage. 80% are the foreign nationals which are filing the patents in India to get it granted. So this is the digital divide we are having. So 80% comes from the outside and 20% comes indigenously. Now, TRL 6 is the level where it is proven that it is able to make the journey to go into the market, GTM. So TRL 6 minimum expectation of any product level is TRL 6. It should demonstrate the product. So capability validated over the range of the parts, TRL 8, that is, you can say it as a, this you can say it as a pilot. This you can say it as a MVP. This is again MVP or a product level that is ready to deploy into the market. Capability validated on the full range and proven system ready for the full deployment into the market. TRL 9. So these are the levels which we are going to call it as a technology readiness level. In the next subsets, we are going to give focus on the academia part. So where government labs and academia comes, so basic research is this one. So we are limiting ourselves to the invention levels. We are having some applied research, then technology development, and then we are having the prototypes and systems. On these scales, this graph is plotted. So these are nothing but this is the TRL 6. Once it passed through this curve, this is known as valley of death. So we are at this level, TRL 3. Technical institutes, they are at technology readiness level 3. We need to bridge this gap. Unless and until we bridge this gap, this would be a valley of death. Most of the products, they goes out of the scene in this valley of death. Once we make it to the TRL 6 level, then we can pursue the journey next ahead one. And then the large businesses, the private sectors, they will put their funding into our projects and they will go into the market. This is how the academia, industry, and investors would show their interest according to the TRLs. This is TRL 1. Okay, the first one. TRL 3, we need to bridge this gap through this value of death. We want to test and come with TRL 6. Then we can go ahead. Okay. These are again investment readiness levels. So this is called as a business canvas. I have put it into some other slide as well. So this goes from no investment, from the friends and family, it will gather the investment. Then comes the angel investors, which is according to the market. This is the right-hand side of the lean canvas. This is the left-hand side of the lean canvas. This is venture capital. According to your project and value propositions, they are going to give you the money. Okay. This is the business model, which here the value proposition, if you could divide it centrally. So this left part, we are going to call it as the lab part or the product part. Most of the product and related features would be here, and most of the market related part would come to the right side. So market is towards the right, and lab or the product will be on the left hand side. This is the lean canvas. Market side, we are going to get the angel investment. From the product side, we are going to get the investors. Okay. Business model canvas, or the synonym word is lean canvas. Section 3. Now, the section 3 is the commercialization and the commercialization of laboratory technologies and its technology transfer. So basic research, as we know, TRL1. So initial scientific research begins, then examples, which includes the studies on the basic material properties, principles which are postulated and observed, the hypothetical assumptions that we are going to test, then basic principles are observed at the basic research, and then focus on the fundamental understanding of the materials and the processes. This happens at the basic research at the start one. TRL2, we can call it as applied research, where some tangibility and experimental work that you go, you support it with the literature survey and go for the applied research. Okay, the practical application. TRL3, the critical functionality you test. You establish a proof of concept that yes, my product is going to make its mark in the market. And according to that, you convince yourself that I'm good at making the prototype out of it. So this is called as a proof of concept, TRL3. Most of our ideas, they are at this level, TRL3. TRL4, then comes the laboratory testing and its validation. This is also called as alpha prototype, or in the layman's language, it is called as ugly prototype. The first versions of your prototype, ugly prototypes, alpha prototypes. Okay. These are designed, developed, and ready for the lab testing, and tested and performed at that level and validated. So basic technology component is tested. TRL4 is the first step in determining whether the individual component will work together as a system or not. Whether all the assembly line that we want to work for the future, whether that is going to operate as per your expectation or not, that is tested at TRL4. TRL5, you are now integrating the system with laboratory testing. It is the scaling of laboratory test. So this all happens at the lab level, and that's why we want to commercialize the lab technologies, and that's why the part I have evaluated for the TRL1 only. The map that we want to showcase now, one simple example I had taken, and I have made it to pass through the process. Okay, you got a new idea of a rubber tire. Suppose you vulcanize the rubber, and it's a very novel type you identified from your research. This combination of rubber and it gives a strength, and that is going to improve the life of the tires. Okay, that idea comes to your mind. Idea, okay. What is the tangibility? Formulating its practical application is the tangibility, TRL2. Preparing the proof of concept analytically, that means meshing, you did applied the materials on your CATIA and Fusion 360 like softwares, and laboratory studies you validated with the pressure points. So you validate your design at the lab levels, that is called as TRL3. So testing of any prototype that we want to go ahead with your design and that rubber type is TRL4. Testing that lab developed prototype with the car system is called as integrated car. TRL6 is the testing it with the operational environment, that is the actual environment, and that's why TRL6 are kept on the right side. So these all 5 are developed at the lab levels, and these all are to be tested with the market. Okay, operational levels. So TRL7, the actual design tested in the real environment. Then ARAI type of a organization, they gives the certification for the use, and then the commercial deployment for the rubber which you thought of as an idea can be deployed as a product in the market. So this is the retro roadmap of TRLs. Okay. Ha graph kalala sagana. Whether the students understood this graph? One simple example, I had run through the process. Whether understood?
Yes, sir.
Okay. So again, the detailed journey of this complex ecosystem, I had just put it many subsets of this. There are legalities which comes like the company secretary, the chartered accountant, the legal and proof of your services that we need to formulate the company. But the process is very simple. Identify a problem or a need, identify the solution for the space. That space you have identified as a solution. Then you can use your technology and gives a tangibility to your idea. So key proof of concept, that doability, whether it is doable or not. On three terms, it has to be tested, whether it is feasible, whether it is desirable, whether the customer wants actually this type or not, or whether it is viable, whether it is going to give you some sort of a money back or not. Feasible, desirable, and viable are the three by which you can test it at this stage. Then we go for the prototype demonstration stage. Then it's rights and approvals. If you are filing a patent out of it, then these many people comes, that attorney, CS and CA, they comes at this part. Commercial production start and production in use is the market one. Now comes the final 5 to 10 minutes I will engage of you, and I will just give you how the patents to be made. For my contribution, I had 4 patents filed and they are published. All 4 are published one. You can search as per my name in the database of IP India, and all Indian patents. And one patent I had filed it at Australia. So that is one another accolade to my profile. You can call it as a patent profile. Once you know that there is a novelty, the first and foremost important step in the filing the patent is novelty. No one else is doing this one in the world, or no one else had already did it. That novelty you should ensure first. Second one is its non-obviousness. That is, what is your inventive step? Non-obviousness means it should not be readily available for any craft or some performer who can do it easily. Okay, non-obviousness. And third one, it should have the industrial use. So these are the 3 criteria. It should be novel, it should have the inventive step or non-obviousness, and it should be the third one is it should be industrially applied one. Okay. Once you are filing the patent one, then according to the patented technology, you can go for either its licensing or you can go for the assignment part. So assignment part and licensing, how they are. As per my knowledge, we should not go for exclusive licensing. Means suppose one company comes, my patent, I am now in a process of licensing it to the technology licensing now. So Visco is one company where biomedical devices we are manufacturing, but and they are pioneering in the biomedical devices which supplies for the physiotherapy and most of the components which are related with the physiotherapy. So they are the giants in this field. So we are talking with them for the licensing one. So can we give them exclusive rights so that totally the product would be owned by them? Don't do that. You should reserve your non-exclusive right so that you can go it with the Visco, then we can go it with the Flamingo, then we can go with the Tynor. So non-exclusivity gives you many branches to open and you can work on the commercial part of it. That is the commercialization of your lab technology. So exclusive rights and non-exclusive rights depending on your need. Okay. So sole licensing for the manufacturing and selling can't be sub-licensed, and relatively they are cheaper and for a limited period licensing. But assignment is like the royalty. So research should convert into the royalty. What is the bottom line of all this discussion? Whatever the research we did, it should give you some sort of a royalty. But one-stop solution, a lump sum amount, he hand over it to you and he takes all the ownership of your patent. You have no say then for the patent one. You just have the paper with you that I have a patent on my name. That's all. But all rights to use that patent in whatsoever the way they want is called as assignment. How this is done, that technology transfer, how that can be done. So for that purpose, we need to sign one process know-how package. This is a document like the term sheet in startups that we sign, a legal document called as demonstration of that technology. Means we know that our product works like this, but we need to demonstrate at the company's end that this is going to prove like this. That is called as demonstration and it's a validation. So that package we need to supply to them. The process know-how package. The name for that document is process know-how package. That means any part of the world you can go and you can work on this process, the same results you are going to get. This is what the authoritativeness with which you can convince them, and this is the conviction that you have for your product. Okay, at any stage you can go for this process and you can validate my process. That is the demonstration process know-how package document. Once you hand over it to them, so you transfer your technology. That is how the technology is transferred in terms of patent with exclusive or non-exclusive rights. If you hand over all exclusive rights, then later you don't have any say for that company that I want to go ahead with another company. No, exclusive rights are owned by a single company. If you go for the non-exclusivity, then the share that comes to you would be very minimal, but more networking and collaboration you can have. Right? Assignment, all of it at one stage, you just get all the royalty and you just sell your license. Okay, there is no another way by assignment, that you have only the paper with you, nothing else. What are the challenges in intellectual property commercialization at the lab stage? We are having the low TRLs. This is the first one. So all lab developed products, they are at TRL level 4 or 5. So 3 is the proof of concept, 4 is the lab validation, 5 is the higher version of lab validation. This is what the picture we are having. So low TRLs, they are not going to give you any sort of a payback. If it is TRL 6 and onwards, then it will find the applications. Okay. Lack of funding for the pilot projects and their studies. Limited market validation, that is the field testing is very limited one. So these are some of the inadequate IP awareness. So we don't have awareness about the IP. So limited technology transfer and commercialization professionals. We don't know what are the legalities according to the manual of the patent office, how the commercialization should happen. Legislative support in terms of the attorneys and the patent agent is very limited one. So there are complex regularities and their compliances. So compliances, like suppose I want to go for filing online patent, so I need to have the digital signature of class 3. That's something we don't know, and these statutory compliances we can't go ahead with. So higher technology transfer cost, no national guidelines for IP valuation. Okay, for suppose my plot is there, or my some farm is there, so that farm is existing. I can, for that property, I can say that this property is having this valuation. According to these norms, this property is having this valuation. But for patent and IP, we don't have any process by which you can test the valuation of your IP. Startups, how they validate and test, the Shark Tank India, you might have observed that they test on their the traction that they got and what type of a funding they are asking for, what is their ask. On that, they judge it. Patents are not technologies, most of them are POCs, and that's why the main problem in India is the POCs. If they are at the level of TRL 6, then they could have the commercialization. So this is the process of commercialization of patent. Signing the technology transfer and licensing is the one. If you want negotiation successful, If no, then you need to stop. Whatever your due diligence is there, due diligence in the sense one document on which, like the term sheet, you agree on terms. So if that is okay, then you go ahead with signing the technology transfer licensing. If not, then you need to stop. Okay. Finally, this is something I want to go ahead with, and I want to conclude my remarks on this. Facebook does not create any content, despite of being the world's most largest media community. Apple, with its sales of more than 200 million smartphones and tablets, does not own his own factory. Alibaba does not own any of its warehouses, despite of being world's largest retailer. WhatsApp, with 3 billion messages a day, does not own any server. Uber does not own any taxis, despite being the world's largest taxi rental company. Airbnb does not own any of its rooms, like Oyo rooms, despite being the world's largest room rental company. Oyo is the subset in India for Airbnb. So what is the bottom line and what is the silver line I want to put before all the students is create the valuable assets and not the physical assets. So valuable assets are the technology one. The physical assets, they are going to remain with that one at that stage only. So if you could able to work on the technologies that are going to play as an enabler role in the future and would change the game, they are the game changers. And with that, I just put this photo in front of you. So we worship Goddess Saraswati. Along with Saraswati, we need to have the patented product with us. So this is a form of Durga, which is having a weapon in her hand. So this is a protection of our intellectual property. And with that intellectual property, we can secure our property intellectually. And with that, we are blessed by Goddess Lakshmi, and she is the goddess of wealth. So naturally, wealth will flow in. And with that, I will say thank you to all the students for the patient listening. And any question, answer is there, then I'm ready to spend some time. Thank you, sir.
Thank you, sir. Any questions from students? Question?
Any questions?
Hello, sir. Good afternoon, first of all.
Yes.
Sir, my question is very simple. So what is the basic difference in innovation and creativity?
Innovation and creativity. Creativity is not something tangible one. Creativity is a thought process. Okay, innovation is a tangible and physical process by which creativity could lead to innovation. If you are having creativity in your mind, like most of us are having some sort of a jugaad mindset or the frugal innovation mindset, that is something which we call it as a creativity. If we are having creativity with us, so one particular task, if we could do it in some another way, but very creatively, which would be appreciated by many of your peers, that is called as a creativity. Something different thought process you applied, which may be a lateral thought process, and using some six thinking thoughts, hats, you did some wonders with the creativity. That creativity leads to an innovative product. So innovation is something, a big umbrella under which creativity is a subset of innovations. Innovation is a tangible product. Hope I could able to give your
Yes,
answer.
thank you, sir. Now I will first make a summary of sir's lecture. Sir has nicely given information about the process of development, and there is need that 94% of the projects are remaining in institute and only 6% project are reached to the market. The purpose of this lecture is students should aware how this our BE project we should be transferred to the market. And after that, sir has given a very basic concepts about innovation. Innovation is equal to M plus E into C raised to X. And as well as innovation is the glue between invention and investment. As well as sir has explained the three phases. First is a entrepreneurial mindset, then second is a customer discovery, and after that business model development. All these three phases are important that innovator should know. After that, what is the prototype, what is there is need to reliability of the product, and also the product life cycle management. And sir has also given examples of different products, okay, right from the pin distilleries to the DRDO products or missiles. Sir has given the different type of innovation product, type 1, type 2, which is very important to know for the engineering student, and they should identify what product they are developing and what type of technology or customers are needed for that particular product. After that, sir has explained the technology readiness level matrix, level 1, level 2, level 3, level 4. All is very important and something related. And sir has also given the technology innovation, a journey needed from complex ecosystem, and how to commercialization of the lab from by using patent through assignment or through licensing. As well as sir has inform the student that technology transfer through patent and what are the limitations for the commercialization and what are the challenges. And thank you very much, sir. This is really a nice session. Even in 1 hour, you have touched all the aspects, okay, which is really complicated to complete this in one session. And our students are, those students, what we are doing, we are in our seminar hall and we are projecting your lectures, and all the students available in the class are second year level student. Still they have understand some basic. This will help our students when they reach at BE level, they will able to commercialize some product or some startup we are expecting. And thank you very much, sir. Now, vote of thanks. I would like to thanks to organizing committee, the coordinator, Professor H.S. Deshpande, sir. I would like to thank our HOD, Dr. S.S. Kulkarni, sir, Vice Principal, Dr. H.G. Kulkarni, sir, and Principal, Dr. K.J. Karande, sir, who always motivate us to organize this type of program so that our students not only get the job, but they will also create their own products and companies for entrepreneurship. I would also like to thanks to all our mechanical department faculties who are directly, indirectly involved in organizing this program. And I would also like to thank to all the students who are patiently listening to the seminar. Thank you very much, sir. With the permission of chair, I declare that the event is over. Thank you very much.